Hello guys, welcome to another video. Today we're doing a question paper. If I'm correct, it's last year's supplementary exam, that is May-June 2020. So it's question 3, and we are given that in the diagram we have the coordinates of A being 5 and 3, the coordinates of B being 0 and half. We are given that we are not given C, and then E is 6 and -4, and all of those coordinates are the vertices of a trapezium having BA and CE parallel. D is the y-intercept of the line CE, and CD is equal to DE. Okay, so let's just look at the questions there. Calculate the gradient of AB. Okay, fine. So now we have the coordinates of AB, right? The coordinates of AB are A, so this is going to be 0.1, and then B, this is going to be 0.2. So now we have to calculate the gradient. So this is 3.1. You have to calculate the gradient. So here it is, 3.1. The gradient of AB. So the equation of a gradient is that m is equal to y2 minus y1 over x2 minus x1. So now we have 0.1 and 0.2, and we said that 0.1 has x and y, and then this is x and y. So now what we are going to do, we are going to find y2. So we go to 0.2 and we find the y value, which is 1 over 2 minus, and then we are supposed to find y1. We go to 0.1. 0.1, it's 3, so this is going to be 3 over then x2, we go to 0.2, which is 0 minus, and then x1, which is 5. So if you type that into your calculator, you'll find that the gradient of AB is equal to 1 over 2. Okay, let's look at the next question. The next question, we need to determine the equation of CE. Okay, let's go back to our information now. We have two parallel lines here. AB is parallel to CE. So what do we know about parallel lines? This is 3.2. We are given that in the information here, we are given that BA or AB is parallel to CE. So now what we know is that in analytical geometry, parallel lines have equal gradients. So meaning that the gradient of AB is equal to the gradient of CE. So meaning if the gradient of AB, we found the gradient of AB as 1 over 2, therefore the gradient of CE is also 1 over 2. But now we're not only looking for the gradient of CE, we are looking for the equation of CE in the form y is equal to mx plus c. So now y is equal to mx plus c, and we already have m of CE, so y is equal to 1 over 2 x plus c. But in the equation or in the line CE, we have the coordinates here E. So we are going to use those coordinates to find the y-intercept. So remember, this is x and then this is y. So y is -4 is equal to 1 over 2, and then x is going to be 6 plus c. And then now if you simplify this, we are going to have 1 over 2 times 6, which is 3, and then take 3 to the other side, becomes negative. So now negative 4 minus 3 is negative 7. So c is equal to negative 7. And then now the equation is y is equal to 1 over 2x minus 7. So that is it. Very simple. Let's look at another question. 3.3 now. We add 3.3. We have to calculate. Now what are we calculating? 3.3.1, we are calculating the coordinates of C. So now what is special about the point C? In the information there, we are given that CD is equal to DE, so meaning that this part of CE is equal to this part of CE. So meaning that D is the midpoint of CE. So what we can do with that, we know that the equation of the midpoint, or the coordinates of a midpoint, is x1 plus x2 over 2 is to y1 plus y2 over 2. Those are the coordinates of the midpoint, right? But now we can take this part and say that, okay, the x coordinate of the midpoint is equal to x1 plus x2 over 2. Okay, fine. So now we have the coordinates of D. What did they say about D? In our information here, they said D is the y-intercept of CE. And we have the equation of CE, which is what? The equation of CE is y is equal to 1 over 2x minus 7. So now, meaning that the point D is the y-intercept, right? And if we substitute x as 0 here, y is going to be negative 7. So that is the midpoint of the line CE. And then now the x value of the midpoint is 0, which is equal to x1. So we need to label our points now. So I'm going to this x, this is y, right? So I'm going to label this point as point 1, and then I'm going to label this point as point 2. So now we have x1. X1, we don't have it. X1 plus x2 is 6 over 2. And if I multiply by 2 both sides, so I'm going to multiply by 2 both sides, and I'm left with now x, or 0 is equal to x1 plus 6. Then now x1 is equal to negative 6. So we have negative 6 here. Fine. Again, y of the midpoint is equal to y1 plus y2 over 2. Then now what is my y of the midpoint? My y of the midpoint, I have negative 7, is equal to, we don't have y1 plus my y2 is going to be negative 4 minus 4 over 2, which gives me negative 14 is equal to y1 minus 4. And then if you take the negative 4 to the other side, it becomes positive. So y1 is equal to 10. So here is my 10 here. So very simple. We've just found the coordinates of C. So what we can do now is say, therefore, the coordinates of C are -6 and, oh, this is -10. Those are my coordinates. Okay, now, what I'm going to do next is look at the next question. Let's see the next question. You are asked to calculate the area of the quadrilateral ABCD. Okay, let's look at our thingy here. Quadrilateral ABCD. So we go from A, go to B, go to C, and go to D. So meaning our quadrilateral is this here, ABCD, right? So what I will want to do is calculate the area. And what type of a shape is this? It's quite an odd shape, but what you can say is that this shape is made from two triangles. So this is triangle 1 and then this is triangle 2. So now what we're going to do is that we are going to calculate the areas of these two triangles and then add them. So let me just highlight the other triangle. So I'll highlight this triangle. Okay, so we are calculating the area. Let me just, yeah, I think it's fine like this. So I have that area, right? And if we look at our dimensions of that area, remember the area of any triangle is equal to half the base times the height. But now the height has to be a perpendicular height. It has to be a perpendicular height, not just any height, and it has to be perpendicular to one side of the triangle. So now in looking for the height, what we can do here, we can use BD as a side which lies on what, on the y axis. And now, because we are dealing with triangles are quite peculiar, because when it comes to height, we can have a triangle here, and let's just say these lines are parallel. We can have a triangle like this, where now the height is inside the triangle, and is perpendicular to one side. So this is the side which the height is perpendicular to. Or we can have a triangle where one of the side is perpendicular to another side, and then the height now is one of the sides. So this would be the height. And then another way is that we can have a triangle here. There's a triangle where now the height is outside. The shape, but it is still perpendicular to one of the sides. So that's what we have here. If you look at if we draw a horizontal line here, it will be perpendicular to our y-axis, and the height now is horizontal movement so it's going to be 5. So we have moved from 0 5 units to the right, so the height here is 5. Similarly, let me just erase this point here, and I'll write it somewhere else, just for us to remember that the coordinates of C is -6 and -10. Fine. So similarly here we have our height outside the triangle and perpendicular to the base. That is our height, and it's still horizontal movement because we have moved from 0 here, we have moved 6 units to the left, so our height is 6. Now when we're speaking about height, where is our base? Our base now is here at the y axis. That is our base, so from B until D. So now how can we use our base here? Remember, we have two triangles now. Two triangles. In triangle, I have two triangles. Let me just say A, B, D, right? A, B, D. In triangle A, B, D, the area is equal to half. Now the base, the coordinates of D, remember the coordinates of D are 0 and -7. So from origin here, we've moved -7 units, and then from origin we've moved half units. So the length of from B to D is going to be 7.5. So it's 7.5. And then now the height of this triangle, the yellow triangle, is outside the triangle, which is 5. So that's how you find the area of the first triangle. And if you look, if you press your calculator, then your area is going to be, that is half. 7.5 times 5 is going to give you 18.75. And then in triangle, let's see, in triangle CBD, now triangle CBD, the area of that triangle is equal to half. The base is still the same. The base is still the same. It's BD, which is equal to 7.5. Now the height is different because it's 6. And now if you press into your calculator, you'll find that the area of that triangle is equal to 22.5. And then now the area of A, B, C, D is equal to 18.75 plus 22.5, which is, if you do your maths correctly, is equal to 41.25. So very simple. There you've just found your area of A, B, C, D. So I'm just gonna pause the video, and then I'm going to remove the annotations to make space for, or let's just continue. The next question, it says that if K is reflected or is a reflection of E in the y-axis, write down the coordinates of K. Okay, fine. Where is K? It's a reflection of E. Okay, E is negative. It's 6 and -4. Okay, let me just note this. E is equal to, or has the coordinates 6 and -4, and is a reflection along which axis? A reflection in the y-axis. So now, reflection in the y-axis, when you have x and y, reflection along the y-axis will change the sign of x, and then y will remain the same. So now we are going to do the same. So it's going to be -6 and -4. So that is k. And if we look at k in our diagram here, we will have k. Let me just draw k in red. We will have k in the same, having the same x value as c, which is -6, but being way up there. Let's just say this is -7 and 6 5 4. Maybe k can be here, somewhere here. So we'll have k here, and then the coordinates of k are what? -6 and -4. So k is here. Let me just put a black dot. Okay, fine. And the question states that we must find the perimeter of the triangle KEC. Okay, so we must plot, or must construct the triangle KEC. The triangle KEC, let me use the red color, né? Okay, triangle KEC. So from K and E, this is horizontal movement, right? And then that is the triangle KEC. And if you look at the point K, what is special about the point K is that it has the same x value as C and the same y value as E. So meaning from K to E, it's horizontal movement, and from K to C, it's also it's vertical movement. So meaning there's a 90-degree angle here. There's a 90-degree angle here. So now, how do we find KEC? How do we find the perimeter of KEC? So if you move from horizontally, from K to E, you have moved from -6 to +6. So that would be 12 units. That would be 12 units. And then moving from K to C, we've moved vertically from -4 to -10. So that would be 6 units. So that would be 6 units. And now we need to find this side, and of which now we know we have a right angled triangle. So I'm going to redraw KEC here. I'm going to redraw KEC. So we have something like this. We have something like this. This is K, this is E, and then this is C. So KEC, KC was 6 units, KE was 12 units, and then we need to find. So, but we know that CE squared is equal to 12 squared plus 6 squared, and we take that from Pythagoras theorem, because we have a right angled triangle and we need to find the hypotenuse. So now this would be square root of 180, which is 13,42. And now the perimeter of the triangle KEC. Let's look at the question. The perimeter of the triangle KEC. So fine. Perimeter of triangle KEC is equal to KE plus KC plus CE. And KE is 12 plus KC is 6 plus CE, which is 13,42. Are we together? So now the perimeter is going to be 31,42. So very simple. The next question. We need to find. Let me just look at the question. We need to find the size of KCE, the angle KCE. Okay, let me just annotate KCE using my thingy. So from K to C to E. So I need the size of this angle here. Need the size of this angle. Let me just shade it here. So I need the size of this angle, but I know that there's a right angle also here. So fine. So what I'll do here, I'm going to construct. Okay, here is KCE, right? KCE, and we had a right angle here. We had a right angle. Okay, so we had a right angle and we need to find KCE. We do that using the angle of inclination. We can do that using the angle of inclination and find this angle here, or use the ratio. So maybe if we just use the ratio, maybe put theta here, and then we have the angle facing theta, and then we have the angle next to it. So now we have the opposite. This is going to be the opposite, and this is going to be the adjacent. And now the opposite and adjacent, from the opposite and adjacent, we can use the ratio. Tan theta is equal to opposite over adjacent, which is equal to, the opposite now is going to be 12 and the adjacent is going to be 6, and then that would be theta is equal to second function tan, and then if you simplify this is 2, right? If you simplify it, this is 2 here, and then if you press your calculator, you'll get that theta is equal to 63,43, and that will be KCE. So very simple, just 3 marks. And remember guys, anyone in grade 12 can master Euclidean geometry and get a lot of marks from the topic. So please like, comment and subscribe, and I'll see you in the next video.